Okay, so for the final challenge here, and this is totally optional for you. This is for the math geniuses. Okay, what I want you to do is grab this thing and pull it up to some height here. I'm going to pick 8 meters. You're going to pick a different height. And I'm going to crank this down to some angle. I'm going to pick 50 degrees. Whoops. Oh, that's so elusive. And I'm going to pick velocity. How about 15 meters per second? Okay, so I'm 8 meters high. I'm shooting at 50 degrees, and it's shooting at 15 meters per second. Okay, now the question is, how far does it go? And we can't use the range equation. How do we do it? Well, we have to use a horizontal vertical table. So let me just talk you through this, and you can do the solving yourself. Okay. So what we're going to do here is set up a horizontal vertical table. Okay. Now notice that it's shooting here at 15 meters per second. Right? So we're going to have to break this into components. There's going to be a horizontal, a vertical component there. Okay. And so this component here, if this hypotenuse is 15, and that's 50 degrees, right? Then this side here is 15 sine 50 degrees. And then this side here is going to be 15 cos 50 degrees. And that's where we're going to start. Okay? So horizontal and vertical. Okay, we know this is going to be 0. X VI. We know this will be negative 9.8, right? And that's T, right? Okay. And then let's figure this out. So 15 sine 50, enter. 15 cos 50, enter. So 11.491. Okay, and then this guy here is 9.642. Okay, so those go in here. So our horizontal velocity is going to be 9.642. This will be 9.642. Okay, and the horizontal x is what we're trying to figure out. Right? It's like that's the prize. Okay, and then we know on the vertical side, we know that the displacement is that we start at 8 and we're going to end up at 0. So we go down 8, negative 8. We know that the initial velocity is 11.491. Now we cannot say that the final velocity is negative 11.491 because that will be the velocity when this thing, it's going to go up, it's going to come back down, right? And when it crosses this line, we know it'll be going down at 11.491. But when it hits the ground, it'll be going down faster. It'll be a bigger number than this, and it'll be negative. Okay? So how do you figure this out? Well, ultimately, we don't care what this final velocity is, but if we try to use no VF to solve for t, it becomes quadratic at this point, right? So let me just suggest this. First, on the vertical side, right, use VF squared, use no t, right? Okay. Use this to solve for the final velocity. Solve for the final velocity. Now be very careful. When you solve for this, it'll be a positive number. But we know that it's not positive. Okay, so make it negative. Okay, you just have to do that because you're solving for the square root of a square, right? Okay, so solve for VF, then use VF equals VI. This is all on the vertical side. Okay, it's all here. Plus AT. Okay, solve this for t. Solve for t. solve for time. And now you'll have the time. The time will go across. Then you can go on the horizontal side, you can just go velocity times time is x. Right? And that's all we ever do, right? The only contenders over here are this guy, and this guy. Okay, so once you get the time, multiply that time by this, right? Okay, hold on here. Not that I'm just doing that right now. Oh no, I'm definitely not. All right. So then once you figure that out, right, you want to move the target to where it's going to land, okay, and then hit fire. Okay. It's like, whoa. If you think it's going to land there, just try it. Oh yeah. Who's your physics teacher? You got to pick a different angle and a different height, by the way. All right, good enough. That's all I need to say, I think.